All right, I'm going to go over chapter 10 today. Before I do, of course, since I was out Thursday, that meant that eventually Charles took attendance. And when he took attendance, this morning he wrote me an email that said, Jeff, it looks like you have several students who have maxed out on attendance and a couple of students who have even exceeded attendance in your morning course. Please make sure you have the paperwork up to date with signatures. It is crucial that you keep up the attendance and calculate in the tardies, get signatures, and process the paperwork if students exceed. All right, and it's on me, but let's see. Two of you in here right now have exceeded, or you're at the limit. So I've got pieces of paperwork for you. After 3 tardies, every tardy that comes in after that is considered an absence. These are not my rules. These are the rules of ranking. Again, like them or not. So someplace on here it says counseled by instructor. You have a pen, right where it says student signature underneath there, please sign it. All right, I'm going to have to give this talk again tomorrow because 2 of the other people who are missing today, all right, 3 of the people who are missing today are also in violation. All right. What's going to end up happening, I'm sure, Charles, I think, is coming back here next week. He's filling in at Perryville, but I believe he's coming back here next week. And when he does, he's probably going to come in here and talk to the entire class. Give the same shtick I just gave. All right? And in the past, and it's on me, it's not you, it's on me, I have let tardies just pass by. In other words, starting next year, I think I told you that after 3 tardies, everything's an absence. Every tardy, that's going to automatically be put into inside ranking. He's upset with me now, I believe, because I have not been following that policy this semester.
I should only be at 5.
Well, I'll believe you, but you know, it's even with those, I have to make sure after 4, I have you sign a piece of paper. The piece of paper you 2 have in your hands now. After 5, you take that same piece of paper and Charles signs it. After 6, you take it over to the other building and Mr. Sutton signs it. After 7, the school is supposed to think about whether or not they kick you out. Again, these are not my policies. These are Rankin's policies. All right? So as far as I'm concerned, you know, today, everybody's got a clean slate. And what I mean is, even if you were late today, you weren't late today. All right? And basically no one was. But the other 3 are going to have to be talked to. And you know what? The weather sucked last night. All right? At least one person who's not here sent me an email saying that they live out in the country, they can't get here. I understand that. But that's why you get 6 absences. Because stuff happens. All right? But I'm going to have to start being a bear on the tardies. So if you're leaving at 7:30, leave at 7:20. All right? Again, in an ideal world, everybody's in here at 8:05. Now, with you 4, that won't affect you next semester because you'll have to be in here at 12:35. With you, that will affect you next semester, but you maybe have been tardy once or twice, and that's been it. All right? All right, that's enough preaching. So I'm on chapter 10, how to design a database. I'm going to go over chapter 10 right now, which is a little longer, but not real long chapter. We'll go over that. We'll take a break, and we will talk about your worksheet. Remember, you had one worksheet that was due last Friday. To my knowledge, nobody gave it to me. And you've got another one that's due a week from today. All right. So I'm on chapter 10, how to design a database, page 277. The author says, in this chapter, you'll learn how to design a new database. Not only do they design a new database, but it is one of the ones that we have been using throughout the examples that are in this book. It's called the AP, or Accounts Payable Database. So as it says, we first learn how to design the structure. The next thing we talk about is how to normalize a data structure. And the last one, which I'm going to skip, is on how to use Workbench. Now, as we start, if you take a look up on the screen here, please. I'm starting up XAMPP. All right, and as we learned last week, I'm going to press admin here to get into PHP MyAdmin. Now, what I'm going to show you, if I remember how to do it, but what I'm going to show you is, let's see, database, SQL, status, user accounts, export, import. And I'm trying to look on here. There actually is a thing set up on here that once you've set up your database, we don't have one, that's probably the problem. So I'll go into sales orders here, the one that we made the copy of. All right. And I'm going to come over here and see if I can find what? Designer. Everybody see this? So I brought up a database, I went to export, and I'm going to designer. Can everybody see that? All right. And I'm going to click where it says designer. And notice what it does. It says some errors have been detected. Don't worry about those. We'll say ignore all. But the point is this. What the system does is it draws a document for you. Now, that's a pretty frigging ugly document. So you'd have to do some work to clean it up. But the point is, it already drew the document for you. So on the last 6 or so pages of this chapter, where they talk about using Microsoft Workbench, you can do it in here. By going into PHP MyAdmin, going to More, going down to where it says Designer. All right. So, starting on page 278, how to design a data structure. Notice what the author says here. The topics that follow present a basic approach for designing a data structure such as a database. All right. So the author gives this 6-step process right here on page 279. Step 1, identify the data elements. What is it that's going to go into the database? All right. At least that should make sense. Step 2, subdivide each element into its smallest useful components. What that means is, if it's the first day of class, all right, and I look at Andrew and I say, what's your name? And he says, Andrew Wolf. Okay, in a database, that wouldn't go in there as Andrew Wolf. It would go in as first name Andrew, last name Wolf. That makes sense? If I said, what's your address? And I know this probably isn't your address, but if he said 123 Main Street, Wentzville, Missouri, 63385. Well, you'd have a street address, which would be 123 Main Street. We'd have a city, which would be Wentzville. We'd have a state, which would be Missouri. And we'd have a zip code, which would be 63385. Does that make sense? Yes? Okay. That's subdividing each element into its smallest useful components. Then, in step 3, you have to identify the tables that make up the system and determine the type of data that you'll hold in each one. Now, if you remember, because I mentioned this to you last week, I'm not sure why the author decided to take the area code for that phone number and make that thing an int, and then take the rest of the phone number and make it a string. I don't know why. But that's an example of not a real good job of assigning data types. All right. Step 4, you have to identify the primary and the foreign keys. Does everybody understand now that a primary key is a unique record identifier? In the past, all right, in the past, people use things like social security number for primary key. But the recommendation is that you never, ever, ever do that. Again, I said this to you last week or the week before, probably last week, but a primary key should be what's called unintelligible, which means that, let's just say that I made a thing in here called student ID. 1, 2, 3, 4, 5, 6, 7, 8. If somebody got your student ID, they probably couldn't do anything with it. It's just a number that really has no meaning. On the other hand, again, if I got your social security number, could do some damage. All right? All right. If I've got, for step 5, or the other thing is a foreign key. We're going to talk more about foreign keys in this chapter. Step 5, this is brand new. Review whether or not the data structure is normalized. All right? And we're going to talk a little bit about normalization. Not to sound critical of any of you, it probably won't make a lot of sense to most of you when we talk about it. It's okay. All right? Finally, step 6, identify the indexes. We talked about an index like the index in a book. Very similar type of a thing. So as it says here, a relational database system should model the real-world environment where you're going to use it. A table represents an object. An object is also known here as an entity. An entity is usually known as a noun. And you know what a noun is. A noun is a person, place, or thing. All right? But it can also be a concept. Again, we'll get into that as we go on. To model a database, you can use what's called an entity relationship or ER diagram. You can take whole books. You can have whole classes on ER diagrams. The author talks in here a little bit about ER diagrams, but doesn't go into them in any detail at all. All right. So then he breaks down these 5 steps. Please look on the page here. This is page 281 in the book. The author says, this is what you've got. Some of the information that's in here, some of the information is not going to change, or at least probably not going to change. Does it make sense to you that this information that's here, that stuff, that's not going to change? Does that make sense? Barring them moving for some reason, Acme Fabrication will be right there. That'll be its name, that'll be its address, that'll be its city, that'll be its state, that'll be its zip code, that'll be its phone number, that'll be its fax number, that'll be its email address. Does all that make sense? Yes? Okay. On the other hand, this is going to change every time there's a new invoice. You'll have a different invoice number, you'll have a different invoice date, and different terms, or possibly different terms. Does that make sense? So you have to start looking at it. So what do we have here? Well, let's say this is our vendor. All right, so that's the stuff we're going to have in vendor. So we'll have a vendor name, a vendor street address, a vendor city, a vendor state, a vendor zip code, a vendor phone number, which again, we're probably going to break all of these down. So a vendor, for now, I'm going to call it vendor phone and vendor fax. We could break those down, that's fine. And a vendor web address. I'm asking you, please take a look up on the board here. Does that make sense? That this is what you get from here. Does that make sense? Every vendor has to be unique, so we probably come in here and have a vendor ID. That's what I get out of this. And again, it would be quite possible to break the vendor phone and the vendor fax, each one of those into two different fields. One that had the area code, all right, and one that had the phone number. I'm not doing that, but I'm just, again, I'm going to try to make sure that you understand all this. Then when we look over here, it looks as though we're going to have what? An invoice number. We're going to have an invoice date. And we're going to have an invoice terms. Each invoice must be unique, so for each one, I'll need an invoice ID. Please look at the board, please. Is there anything in here that doesn't make sense? All right. Then these things that are in here, this stuff, this would be the invoice line item. So I'm just going to call it invoice LI for line item. So we need a line item part number. Quantity. Description. Unit price. Extension. And since each set of line items, an ID. Please take a look at what's on the board and tell me, is there anything that's up there that doesn't make sense? The reason I'm asking you that is when you do your last assignment, I'm going to say, I'm going to give you something, and it's going to be basically mimicking, mocking, whatever you want to say, what we did earlier. If you remember, the last C# we did, we had what? We had people who were hourly, we had people who were commission, we had people who were piecework, and we had people who were, I don't remember, I think there were 4 of them. But I'm going to give you something like that, and I'm going to make you do this. So again, any questions on this? Would you be able to figure out, I mean, looking here, this would be an int, right? String, 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 string. And really, also here. Does all that make sense? Looking over here, int, invoice number. I don't know, we still might end up making that as very well a string. This is going to be a date, invoice date, and the terms, string. ID, int, part number, again, int, quantity, well, I would say that'd be an int. Description, string, unit price would be some kind of a double, and the extension would also be some kind of a double. All right, does all that make sense? All right, for those who are not here, probably won't help much, but because again, this will be the last assignment on databases that you're going to have in here. All right. So the author says this is what they pulled out. Let's look at what they've got as opposed to what I have. Vendor name. I got it. Vendor phone number. Vendor fax number. Vendor web address. Invoice number. All right. I've got this, the other information that's in there, but that's fine. The invoice. The date. The terms. Etc. All right. And what they've done is they've just pulled everything out and said, hey, what are we going to have to do? What are we going to have to use in here? All right. So as the author says on the bottom here of page 281, depending on the nature of the system, you can identify data elements in a variety of ways. Sometimes you're going to have to go talk to people. You get a form. I had this at a job I was at. I had to take this form and automate it. And not like this is haha funny, but you might find this interesting. All right. So I went over and I talked to people, and I was able to identify every single field on this form except one. And I said, well, what is this? I don't know. I would go to another group. What is this? I don't know. Go to another group. What is this? I don't know. Okay, then I'm going to remove it. No, don't do that. Are you using it? No, but we might. And they didn't want to. So we had to put a dummy field in there that didn't do anything because no one knew what it did. The documents used in a real-world system often help you identify the data elements. That's what I just showed you. As you identify these data elements, you should begin thinking about the entities they're associated with. This is what I mentioned before. Please look on the screen on page 283. As mentioned before, hey, what's your name? Andrew Wolf. You want to break that down into two fields. That should just make sense to you. If I say, what's your address? You're going to break it down into multiple fields. All right. So as it says, if a data element contains two or more components, you should consider subdividing those components. The extent to which you subdivide depends on how it's going to be used. All right. Next, 284 and 285, how to identify the tables and assign the columns. Again, please look on the screen. The author has now broken this down into 3 different tables. Some of them, he said, ended up being duplicates. So he put a line through them. Some of them are going to need to be used in more than one table. So he put an asterisk after them. Notice account number, account number, account number. Terms, terms. Invoice number, invoice number. All that makes sense? By doing that, you're able to start to identify the relationships that you're going to need to make between the different tables. And that's what the author is talking about here. Again, I don't want to sit and read his stuff. This is how the author does it. That doesn't necessarily mean this is how everybody does it. Looking on pages 286 and 287, how to identify primary and foreign keys. Well, if we take a look in there, these are the 3 tables that you have. All right? And when we look, notice that what we have here. We've got a vendor ID. We've got an invoice ID. Everybody see these? And here, we've got an invoice ID and a vendor ID. So what we have in this table is this field, this field, which allows us to link to here, and this field, which allows us to link to here. Does that make sense? The main job of this table right here is to be able to link the other 2 tables together. If we didn't have this table, there'd be nothing in common where we could link together the other 2 tables. All right? And when you do this stuff, you can buy books that say, the science of database. It's baloney. There's a lot of different ways that this can be done. A lot of ways that you can do it that would all be correct. All right? Did you hear that? There's different ways of doing the same thing that would be correct. So how do you know what's the best? You don't. You do it the way that seems to make sense. You run it by other people. Once they bless it, boom, everything's fine. This right here is what's called a one-to-many relationship. And that's what you want, is what's shown on the top. So every one vendor can have 0, 1, or more invoices. Every invoice can contain 0, 1, or more line items. Does that make sense? All right. What you don't want is this, a many-to-many relationship. When they first did this, they had these two fields, these two tables. Employee ID, first name, last name. Committee ID, committee name. Notice there's no field in common between the two. So you make a separate table. It's called a jump table or a join table or a linking table. And all this has is the primary key of this one and the primary key of this one. That's how you play with a many-to-many relationship. When you've got a one-to-one relationship, what this means is this could have been put in one table. So imagine that what I had in one table was this. All right, I had the employee ID, I had the employee first name, the employee last name, the employee, let's just say, street address, the employee city, the employee state, the employee zip. We'll leave it there. And now each employee, so we're putting here employee ID, employee department number, and employee department name. And if you look up on the screen here, please, I put this into two tables. This has got the employee's personal information. This has got the employee's employment information. This could have been put in as one table. Some people do it that way. But if you don't, if you break it up into two tables, that means you've got a one-to-one relationship. So every one thing over here would have one thing over there that matched it. All right? And that's what the author is talking about on the bottom here of page 287. Again, I don't want to read to you. But you can look at that and hopefully try to start figuring out the differences between one-to-one, one-to-many, and many-to-many relationships. Next, how to enforce relationships between two tables. All right, page 289. Operations that can violate referential integrity. What referential integrity says is this. I want to go back to what we looked at before because I can show you, I think, this way, right here. All right. Imagine, and this is maybe the most important part so far, so if you please look up on the screen here. Imagine that I remove this vendor. Okay? I don't care who it is. Could be that Acme fabrication, it doesn't matter. But if I remove that vendor, and that vendor still has outstanding invoices, for lack of better words, I'm screwed. Does that make sense? The vendor is now gone. They owe me money, but since their information is gone from there, I'll probably never get it. All right? So what they're talking about in there is, okay, if you remove a parent, what do you want to do with the children? That's exactly what they're saying. If you remove a parent record, what do you want to do with the children? And as they say right here, you got your choice. Some of these are going to sound a little morbid, but when you delete a parent, kill the kid. So if I remove the vendor, any records associated with that vendor are removed automatically. Okay? That's the most extreme rather, but you can do that. The next thing I can do is if I remove the parent, set the kid to null. All right? And that's what they're talking about in here. So this whole topic on the bottom of page 289, what is referential integrity? It's making sure you don't have what are called orphan records. All right? Records that exist that don't have a parent. All right? All right. The next thing, starting on 290, and it's on 290 and 291. And then we're going to see it again in just a couple minutes. But they're going to talk about normalization. What you don't want to do with a database is you don't want to repeat things any more than you have to. All right? Please look up on the screen here. Did you notice in that first example, Zyka design is in there twice? Everybody see that? What if it gets put in, and in one case they spell it ZYKA, and the other one they spell it ZIKA? Then technically, those are two different companies. What you want to do with Zyka Design is have it in there only once. And then associate in a table the vendor name and an ID that goes with it. Then in these tables here, all you put in there is that vendor ID. All right. So you've got repeating columns, you've got redundant data. You don't want to do that. You want to do what's called normalize the database rather. It says here, normalization is a formal process you can use to separate the data in a data structure into related tables. We're going to look at that in just a minute. All right. Next, they talk about indexes on 292 and 293. And they say, when do you create an index? If you're in doubt, you create one. You may or may not be aware of this, but there are a lot of software packages out there right now. So if I'm writing a book and I put a term into the book, all right, that what will happen is immediately, as soon as I put the term into the book, depending on the codes, etc., that I use when I'm keying in the information for the book, it'll immediately put an entry into the index of the book. All right, and you can do the same kind of thing with a database. You use indexes because they speed up performance. Bottom line, that's it. All right. Please look up on the screen again. I'm on page 295. They talk here about normal forms. And if you notice, they have 1, 2, 3, 4, 5, 6, 7 normal forms. All right. Typically, all you do are these three. Those are typically the only ones you worry about. Unless you're a person who's working in academia. So in other words, if I'm a professor of databaseology type of an idea, I might explain the rest. But all we care about here are these first three. So 1NF, which is first normal form, 2NF, which is second normal form, and 3NF, which is third normal form. Again, please look up on the screen. If you're in second normal form, you must already be in first normal form. If you're in third normal form, you must already be in second normal form. Does that make sense? So if you're going into third normal form, you have to automatically be in first normal form and second normal form already. All right. So each time you go into one of these normal forms, it supposes that you are in the normal form above that, and above that, etc. I don't want to read to you, but it says here, for first normal form, you don't want stuff to repeat. That's what it's saying. No repeating columns. Second normal form, every non-key column has to depend on the entire primary key. Third normal form, every non-key column must depend only on the primary key. So let's take a look at some examples of these. So they talk about first normal form on pages 296 and 297. You already saw this thing. Zyka Design right there, Zyka Design right there. Okay, you see all that stuff. Okay? Now, I'm going to tell you that, yeah, they say this is now in first normal form. I'm not going to disagree with them. But this right here, you should have another table. You know, you might call it, for example, vendors. And maybe the only thing that thing has in it is a vendor ID and a vendor name. So, for instance, this could be 1, Kaner's Publishing, 2, Zyka Design. Can everybody see this, what's on the screen right here? All right. Now what I'm able to do, since I have this, is I can replace this with vendor ID. And this will be 1, 1, 1, 2, 2, 2. And now that whole thing is gone. The advantage of doing that is if I only enter that information in once, I never have to worry about somebody spelling something wrong there. All right? That's why you do it. Because people are fallible. They're not infallible, although some of us think we are. No one is. So it says here, for a table to be in first normal form, its columns must not contain repeating values. Okay? Then it says a table that's in first normal form often has repeating values. So what I was showing you was actually sticking it more into second normal form. See that? The other thing that this is saying right here is if the key field in here is invoice ID right there, then if I know the invoice ID, I can figure out all the other information about this, everything. All right. So for second normal form, every non-key column must depend on the entire primary key. Okay. Now I'm going to show you an example of doing something stupid. All right. So I'm going to put in here M first name, M last name, M street address, M city, M state, M zip. I'm asking you a question. Look at what's up on the screen here. M first name, M last name, and street address, and city, and state, and zip. Okay? So what it's saying here is every non-key column must depend on the entire primary key. So I come up here and I make emp ID. Everybody with me? So what I'm saying is if I know that Evan's emp ID is 4, then I can tell you his last name, his first name, his last name, his address, his city, his state, and his zip. Would you agree with that? I would. All right. And that'll work fine. This will be in second normal form. But here's the problem. Next, what we want to do is we want to get into third normal form. All right. Here's the problem. So if I say, hey, Evan, what's your zip code? And Evan says 63385. Okay, everybody with me? It says 63385. All right. Then would you agree with this? That once I know his zip code, I can tell you the city he lives in, and I can tell you the state he lives in. Would you agree with that? Maybe you've had this happen to you for a long time. When I was living in Illinois, back in like the 90s, I would get called almost every night by telemarketers. And they'd always go, can I have your zip code? All right. And if I said, whatever it was, 61329, they'd go, oh, are you in Bolingbrook, Illinois? They would be verifying that. So they knew my city and my state based on my zip code. All right. So even though this table is in second normal form, it's not in third normal form. Typically what I do is I make another table here that would be called like zip, and I might have in there a zip ID, all right, a zip, maybe a zip city, I don't know, and a zip state, whatever. It wouldn't matter, but the point is, the problem with this table as it currently exists is if I know your zip, I can tell you your state and your city. That's violating the rules. All right? And that's what they're saying here. In our case, it would be, does the employee information depend only on the ID? So the answer is no. And so in here, when they put this in the third normal form, if you look, every time you put it into a lower number normal form, you add more tables. That's what it all boils down to. So for a table to be in third normal form, every non-key column must depend only on the primary key. If it doesn't, you end up making it into a new table. All right. The opposite of normalizing is what's called denormalizing. All right. So when you normalize, you're taking it and breaking it up into more and more tables. Sometimes, what ends up happening as you go, into these deeper and deeper normal forms, you might have 25. You've got 25 total fields. You started out, you had 3 tables. So each one had about 8 fields. Then you broke it up, and eventually you got in the third normal form, and now you've got 16 tables. And each table has an average of 1.5 fields. So you've got more tables with less fields. The problem is, now when you join, you're joining together 5, 6, 7, or 8 tables. That's a waste. So when you normalize, you're expanding. When you denormalize, you're contracting. You keep that in mind, that's fine. Again, I'm not going to go over the MySQL Workbench design stuff on 304 to 309. So that's it. Let's take a break. When we come back, we'll talk a little bit more about normalization. And when you come back, we'll also take a look at some of the problems on your second worksheet. So let's take a break. It's 8:55. Let's please come back at 9:10.